Hello everyone, my name is Aniket Devkar. Uh, Today I am presenting a capstone project on a live class monitoring system. That is nothing but the deep learning MLE project. So how this idea comes from? Because we are running in the COVID-19 situation. So education is a main agenda for this time. But when a student are in front of a teacher, so teacher can understand their expression, how they understand the topic that they teach by their teacher. But right now, all whole education system is going to be online. So teacher couldn't know their feedback of or understanding of the students. So it is important to got the feedback from students. So in that time, face emotion recognition gives us feedback like happy, sad, or fearful or surprise. So this is a main motto of to creating the this project. So in this project, these are the contents. First at all, introductions of face emotion recognition. After that, the problem statement, and how many that's been model creation. After that, what is the loss and accuracy of the models, and deployment of Streamlit web app in Hiraku and Streamlit, and output, that means various prediction images from the web app that we made, and challenges that faced in the project, and conclusion, and last one is some real life experience from the project. So what, first at all, introduction. So what is face emotion recognition? Face emotions are important factor in human communication, as you know, that helps us to understand the intention of other person. In general, people in states of the people, such as joy, sadness, anger, using facial expression, because two-thirds of communication is conveyed by the emotions. Because of the feedback. In online, teachers couldn't get the feedback from the student, because there is no facility like getting feedback from how understand this topic to the student. So it is important on that aspect. So what is the scope or future scope? First, future scope is for education, and after second is for medical healthcare, because patient feeling is important for the doctor to know his expression or wellness, and third one is in the emotion recognized in the video game testing. For example, a developer gives a demo to the some people who got a feedback of that video game, because if the people are satisfying from that video game, that means this video game is popular or good for the people. If they give a sad expression from the that game, so that's nothing but it's bad. It bads for the developer to build the model. So our problem statement is nothing but the Indian education landscape has been undergrowth and rapid change for the past 10 year, ongoing the advancement of web-based learning services, especially for e-learning platform. That's been whole education system are revolving around to the e-learning platforms. So data summary. So we'll build a deep learning model which detect the real-time emotion of student through a webcam, so that teacher can understand if student are able to grasp the topic according to the student. So the we use the far 2030 dataset for our project. It consists of 35,887 Grayscale and 48 into 48 size of images with 7 emotions like angry, disgust, fearful, happy, natural, and sad and surprised to know the expression or feedback from the student. So here is the Kaggle link. We get a data set from the Kaggle, and it is good and very clean data set to use for our model. It having 7 levels, just like as angry, disgust, fear, happy, sad, with testing or training data. So what are the dependencies of our project? So these are the package that we are using in the project. It's like Python 3 and TensorFlow, Streamlit and Streamlit WebRTC. These are the dependencies. So after that, what is model creation? We create our model using three method. First is we using deep face. Deep face is a facial recognition system by Facebook for tagging images. So it perform on 4 stages. First at all, detect, align, and represent and classify which expression is giving by the student. So second method that we are using, that is nothing but CNN. So what is CNN? CNN is a convolution neural network. Is a main category to do image recognition or image classification or object detection or recognition. Face are the main idea where CNN are widely used. CNN image classifier takes an input and process it and classify it under certain category. First of all, comprise input to the is nothing but the array of pixel, and it depends upon the image resolution to use convolution neural network because it having a training accuracy about 66% and testing accuracy about 56%. And in that we see that the image first convolution neural network are revolving around the future maps and polling, and the final are not even fully connected layers. First feature map is perform. After that, polling layer section will reduce number of parameter when the image are too large. After that, all the last 3 layer are connected to each other to get the result. So third and last method that we are using, ResNet 50. So what is ResNet 50 is that's been convolution neural network that is in using a 50 deep neural layer. So you can load up predefined version of network and train on more than 1 million image from the image on data ImageNet dataset. Predefined network can classify into thousands of image categories, such as many animals or a pen pencil. And it is very rich feature of representation of a wide range of images. And the network has the input image input size of 224 by 224. So we build our model by this is a loss accuracy and precision plot using ResNet. So first of all, accuracy is revolving around the train accuracy about 85 point something, and also trace accuracy is also nearer to the same, but at 20 epoch it rapidly down, and there is a very less loss into the precision uh, precision with resonate, and this whole graph is with respect to epoch. So the next is loss and accuracy plot using CNN. So as I told earlier that our training accuracy is around 65%, and validation or testing accuracy is about 56%. So there is somehow good loss, very less loss into the CNN network. So next is deployment of Streamlit web app in Heroku and Streamlit. First of all, we deploy the app in Streamlit, but because of some requirement, we don't run this app. We're facing some error with when we are dealing with Streamlit. So that after we use Heroku, and then we start deploy the app. If you saw in the starting section of GitHub repo, you see app name face 46, but it not deploy. We tries as much as possible, and then we put the link of app, but in local system in run properly, and she's also fine, but we don't stop on the that conclusion. We will definitely rectify the error and put new app as soon as possible. So these are the output of our model. So these are various prediction of images from the web app. First allow sad, happy, neutral, natural, and surprise and happy. So the challenges that we face when we are going to complete our project. So first is large image data set to handle, because there is very large data set around 35,000 or 36,000. It is difficult to handle with that data set, and after that, because of that much data set, couldn't able to take GPU with the um, Jupyter notebook, and we tried only 3 models because of we don't have much faster computer, so that's why we restrict our onto the third model, 3 methods, and continuous runtime and RAM crash due to large dataset, and careful and tune hyperparameters. So at the last, after completing this project, we made some conclusion depending on the um, model. So the model which has created by CNN layers gave a training accuracy of 66%, as I told earlier, and test accuracy of 56 that I showed in the graph in the recent slides. We have also included the video of my web app working in locals, and the code which are deployed are in GitHub repository. It was such an amazing and interesting project that we learned a lot from this project. So some real life experience from projects, understand the deep concept of the project, and also concept of some deep learning topics, and don't afraid from the failure, never grip or never give up or never restrict with that boundaries, and have some patience. Bad time definitely passed away, and try new things and execute your idea. So thank you.